Good evening. Welcome to one more interesting webinar of RATA Bangalore. Before I proceed, let me first introduce you what is RATA. RATA means Refrigeration and Air Conditioning Trades Association Limited. Its head office is in Mumbai and it was started in the year 1949. That means we are in the 73rd year of existence and we are the oldest refrigeration air conditioning association in Bangalore. RATA has 1,321 members as on today and it operates through 13 chapters across the nation. There are chapters present in Mumbai, Bangalore, Chennai, Hyderabad, Madurai, and so on at 13 major cities of our country. The goal of RATA is making progress and achieving success for its members. RATA is a very wide umbrella of manufacturers in HVAC trade, traders, contractors, service providers, and everybody who is connected to the line of HV and AC. RATA conducts webinars across its various chapters on a regular basis, and these webinars are mainly conducted on commercial activities of the traders. The goal of RATA is unite trade members so they can collaborate from each other, engage with central and state government and get benefit for the trade, and then develop a knowledge bank. If you get into the knowledge bank of RATA, you will see hundreds of webinars which are still available, and you name on any subject. It could be on ESI, PF, or trade laws, or partnership deeds. You name anything which a businessman requires in the line of HVAC, it is available there. There are also many technical topics which are available always. RATA is ably managed by its president at Mumbai, Mr. Ajit Panikkar. He runs a company by name Pureblu Technologies Private Limited. In Bangalore, we are 78 members strong. We have a president, Mr. S.S. Subramaniam, who is a consultant by profession. RATA Bangalore is also a member for FKCCI. RATA Bangalore corresponds with the state government and the central government along with the head office RATA at Mumbai. The various issues pertaining to the trade are taken up collectively and presented to the state and central governments. Thereby, RATA provides a very large umbrella for all the traders in HVAC, for all the members in HVAC trade, and help them in building their business. Today, as I told you, we are going to have one more very important webinar, a webinar which is very close to us, our line of activity, what we are doing. And we have a very eminent speaker with us. And to introduce this speaker, we have our own Mr. Nagaraj. Mr. Nagaraj is the proprietor of Blue Volt. It's an electrical contracting company building various electrical components and equipments. And now it's Mr. Nagaraj. Over to Mr. Nagaraj for introducing the speaker of the day, Mr. Nagaraj.
Thank you so much, Prasadji, for introduction, for my introduction also. Thank you so much.
Okay.
So it is my things to introduce our today's speaker. He is a well-known speaker. Mr. Madhukar is the well-known speaker in RATA, ISHRE, and ASHRE. He is the CEO of ASHRE. Sorry, he is the CEO of the company called Climatics. They are the dealers for Carrier and Toshiba products. He is a diploma in MRAC, over 30 years experience, almost 3 decades, sales, service, design, and project execution in HVAC. He is a member of RATA, FKCCI, past president of ISRE and ASHRE Bangalore chapter. Currently he is holding a national chair in student activities of ISRE HQ. Delivered so many lectures in ISRE and ASHRE. He is the ISRE DL also. I request Madhukar, over to you, please.
Thank you, Nagaraj, for that excellent introduction. So without wasting much time, I will start sharing my screen. Good evening and welcome to all of you for this second part of this webinar, what we have termed it as types of air conditioning application. And we would be discussing about various types of application. Without wasting much time, I will share my screen. Hope all of you can see my screen now. So this is what we would be talking about. We would be talking about the types of air conditioning applications. In the first part, just to brief you, in the first part, we had discussed about data center air conditioning systems, some specific application air conditioning systems in the first application. And now in the second part of it, we would be talking more about the most important part, which is very commonly used and most close to most of our hearts. So what are the applications which we would be discussing today? We would be talking about residences and showrooms. We would be talking about educational institutions, industries, hospitals and laboratories. Why hospitals and laboratories are put together is more or less the type of air conditioning system required for hospitals and laboratories are same. That's why we have clubbed it together. Then, so like what we said, I generally start my presentation with the basics of what we need to understand. If we have to cool a place, we need to remove heat. So what is that heat? Heat is a form of energy, and heat cannot be destroyed, but can be transferred from one substance to another substance. Generally, it moves from a warmer region to a colder region. So we express unit of heat in British thermal unit. Let us say, for example, when we talk about the capacity of the air conditioning system, we generally talk about in BTUs, that is British thermal unit. So what is 1 BTU? 1 BTU is the amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. That means, let us say, to be more precise, if you have 1 pound of water and that water is at 10 degree Fahrenheit, if you have to raise the temperature of 1 pound of water to 11 degree Fahrenheit, that means you have to add 1 BTU of heat. So similarly, it is vice versa. If you have to cool that heat, you have to remove, if you have to cool that water, you have to remove 1 BTU of heat. This is what is defined as 1 BTU. So what is ton of refrigeration? Generally, we all talk about 1 ton air conditioning system, 1.5 ton air conditioning system, 200 tons, 300 tons. So what do we mean by that 1 ton? 1 ton means it is the rate at which the heat is removed. That means if you have a room, let us say, for example, you have an enclosed space of say 150 square feet or 200 square feet, and if there is 12,000 BTU of heat in that particular room, then if you have to remove that 12,000 BTU of heat in 1 hour, then you need a 1 ton of refrigeration air conditioning system. So this is the common terminology. In other words, it is 3000 kilocalories per hour. We are also talking about kilowatts and HP, because in the latest technology, what we talk about inverter technology or our VRF technology and things like that, we generally discuss in terms of kilowatt or in terms of HP. So 3.5 kilowatts is equal to 1 ton of refrigeration. Please note, this is not electrical kilowatt, but this is cooling kilowatt. Then it is equivalent to 1.25 HP. So let's straight away move to today's first topic. Generally, when we talk about air conditioning of a residence, we have various zones, various places to be cooled. So what are those important areas of consideration? Let us look at it. Why air conditioning in residences? Air conditioning generally enhances comfort. If you just Google human comfort says that the condition of mind which expresses satisfaction with thermal environment. That means if you are sitting in a comfortable temperature zone, that means your mind will not be stressed. You will be comfortable and you will be able to give 100% through your mind. Your concentration will be higher. You will be more focused. You will be able to achieve whatever you want. So Thus, human comfort provides a human-friendly environment by controlling properties of air. So now, what are those properties of air? Properties of air is nothing but air conditioning is a process where you control temperature, humidity, movement of air, cleanliness, and odor. Now, all this should be simultaneously controlled in an enclosed space. That is known as air conditioning, and that is what we say in a controlled zone also. So all these things to be controlled, that is your temperature, humidity, movement of air, cleanliness, and odor, are to be controlled if we have to achieve air conditioning. So then, residences, what is the temperature for human comfort? The general comfort level of human is between 24 degrees centigrade to 27 degrees centigrade, and relative humidity between 40% to 60%. So generally, when the first long time back, I was just discussing with a couple of doctor friends of mine. I was just asking them, what is human comfort? So the answer they gave me was, you will be comfortable as long as you don't sweat. That means if your body starts sweating, you start feeling uncomfortable, and you don't sweat as long as you are in the temperature zone of anywhere between 24 degrees centigrade to 27 degrees centigrade. So this is the comfort zone, and this is where the human body or human beings tend to be in a comfort zone. Then, so what are the areas that we need to look into when we talk about residences? We talk about living and family, we talk about bedrooms, we talk about dining area, we talk about home theater, we talk about gym, we talk about personal bar. Please note that each of these zones may be requiring different type of system. Let us say, for example, living and family, you would have a lot of open space. So when you design living and family, you need to design the air conditioning capacity at an optimum temperature. Similarly, bedrooms is something which you are going to have a confined space. Maybe you can have an adequate air conditioning system available in your bedroom. Dining area is again going to be a lot of open spaces around. We need to maintain optimum temperature. Home theater is again where a lot of importance needs to be given. For example, if you have a typical home theater which has got your wall acoustics, your audio systems, everything, these systems emit a lot of heat. So we need to take proper care to design the right capacity of air conditioning system in a home theater. Then coming to gym, generally you go to gym to sweat out, you go to work out. It doesn't make sense in having 19 degrees centigrade in a gym and then you struggle to sweat. You tend to overwork, which could damage your human parts. So in addition, so the best probable suggestion what I can give for gym is that maintain a temperature of 25, 26, but at the same time also have a lot of ventilation system in process. That means please bring in adequate fresh air so that the stale smell of sweat and everything is removed in a gym area. Similarly, the same case with respect to bar also. When you have a personal bar, the liquor smell or you could be having a lot of carpet smell and things like that. Your food items could be smelling, or if somebody has the habit of smoking, then the smoke smell has to be removed. So similarly, in a personal bar also, we need to have a lot of air changes, which are very, very important in addition to controlling the temperature. So we need to have these adequate air changes in addition to the air conditioning when it comes to gym and bar. So then let's move on to the next segment, that is showrooms. So generally, what are the various types of showrooms? I'm sure most of you, if you walk across one street across the road, you will find plenty of showrooms. And just to picturize, if you have just put an automobile showroom, I put a jewelry showroom, I put a consumer goods showroom, and of course today interior design is fast catching up. You have a lot of modular kitchens, everything available there. So these are some of the systems where you find commonly an air conditioning system in place, an application. So like I said, jewelry, ready-made garments and textiles, electronics and consumer durables, supermarkets, groceries, opticians, personal wear, building materials like granites, kitchens, marbles, sanitary ware, etc. And of course, automobiles, where I had shown the pictures. See, each one in this application has to be, some special care has to be taken. Like for example, a jewelry showroom would have lot of lighting available. So you need to calculate when you do the heat load for a showroom of a jewelry area, you need to consider the lighting into consideration, because generally jewelry would have almost 3 to 4 times the lighting of what you generally have for a showroom. So special care has to be taken when we do the design in considering the lighting. load. Similarly, ready-made garments and textiles, they emit lot of heat. The textiles and garments displayed in the showroom emit lot of heat. So we need to take adequate care and special care when we do the heat load in when we design garments and a textiles showroom. Electronics and consumer durables also, let us say for example, you have an air conditioner or a refrigerator or a television on display there. Those equipment emit lot of heat. So we need to consider the equipment load when we calculate the capacity of the showroom for an electronics and consumer durables. Similarly, supermarkets, you might have seen all the supermarkets and grocery areas. I will talk both these together because they are common applications. They would have a lot of refrigeration system. You would have display cabinets where vegetables are stored, fruits are stored, you would have groceries on display. So all these refrigerated cabinets emit a lot of heat. Those are direct heat which needs to be removed from this air conditioned space in order to maintain the temperature. So we need to take special care to consider this equipment load, that is your refrigeration equipment display cabinet loads, when we talk about air conditioning. And also in supermarkets and grocery areas, you would have a lot of occupation load. That means a lot of human beings, a lot of people would be marketing. However, when you open the supermarket or a grocery store, the rush may be less. Maybe between 9 to 12, the rush may be less. But as you go on during the day, say between 12 noon to say 7 p.m. or 8 p.m., the supermarkets would be crowded. So you need to consider all this optimum design when you make a design for a supermarket or a grocery shop. Similarly, opticians and personal wear, we do have a lot of opticians also nowadays where they need to maintain the dust-free environment. Otherwise, these fine dusts can get in and stay on your spectacles. And when you wipe those spectacles, there's a possibility that you could get scratches. So you have to, it is preferable to have a dust-free environment in an optical showroom or a personal wear showroom like a watch showroom, etc. So then building materials, like today we have granites, we have kitchenettes on space, on display, we have marbles, we have sanitary ware. So these also, lot of lights would be used to display to make these items look very nice. So this also, when we do the heat load calculation, we need to consider specific lighting load for these building materials also. Then coming to automobiles, again showroom, in case automobile they start the vehicles, and a lot of carbon monoxide or carbon dioxide fumes would be emitted by these vehicles. We have to make sure that we have adequate ventilation or air changes to remove these automobile smoke emitting carbon monoxide, etc. So we have to take special care to remove these things also. Now, coming to what is the types of why air conditioning is required in a showroom. One is to enhance human comfort, keeps the environment clean and dust free, like I have explained to you in the earlier stages itself. And most important is it reduces a lot of noise. And because of this noise, you could have a lot of disturbance and you may not be comfortable inside a showroom. And at the same time, having air conditioning in showroom will have a good ambience. That means people will like your ambience. People would like to walk inside your showroom if you have air conditioned showroom. So that is why it is important to air condition your showroom. Then what are the challenges when we talk about showroom air conditioning? Generally, what happens is when you design an air conditioning system for a showroom, like I said, you need to consider these lighting areas, etc. Then operational cost, like the showroom would be open from 9 a.m. to 9 p.m. or 10 p.m. What would be the operational cost on your power bills? A lot of showrooms have a bad habit of switching off the air conditioner when there is no customer and switching on the air conditioner as soon as the customer comes in. But there's a flaw in this kind of an operation, because by the time the customer walks in, you switch on the air conditioning system, and by the time the system cools the space, the customer would be on the verge of walking out. So that means the customer would not be comfortable. So personally, I would recommend that go in for an inverter type of an air conditioning system. Keep the temperature adequate at about 25 degrees centigrade throughout the day so that it consumes optimum power, and you also save a lot of energy bills when compared to a fixed speed air conditioning system. So the cost and the initial cost, apart from capex, you need to consider the operational cost as well as return on investment when you start spending on an air conditioning system. Similarly, like I said, adequate fresh air. You need to definitely have adequate fresh air, especially if you are in a zone where there are a lot of pollutants in and around you. You need to have a proper ventilation system. Otherwise, a person inside the air conditioned space may not be comfortable. And at the same time, like I said, your grocery areas, your supermarket, there would be a lot of people walking in and walking out. You really never know at which point of time the market would be attracting more customers, or at which time there would not be any customers. And also frequent opening and closing of doors if you have customers walking in and walking out frequently. So these are some of the challenges that you need to consider while you design a system, especially in showrooms. Then moving on to the educational systems. Similarly, in educational institutions also, today a lot of institutions are becoming more and more sophisticated. You have more and more, like for example, most of the systems, most of the classrooms now do have projectors. The classrooms are projected on a screen. You never have a whiteboard and a duster where they use an electronic pen, or they use a TV, and the TV itself works as a screen, and people write on that. It's an electronic screen or a digital screen. People write on that, like in this screen also we can write now. Similarly, those are the kind where you have to have a dust free environment, or those kind of projectors emit some amount of heat which needs to be removed, then reduces unwanted outside noise. There would be a lot of noise on the roadside, etc., if the education institution is in a busy area. So that would, if you air condition the space, generally you enclose it, that would reduce a lot of unwanted noise. At the same time, students also get attracted if you have good ambience, lures students to the institution, better environment for students. Like I said, their brain starts working more efficiently at a controlled temperature zone. Then, what are the challenges in educational institutions? Designed due to high volume of space, each classroom would have about 150 people, 120 people. So there is huge challenges there that needs to be considered while designing. Again, operational cost on return on investment, like showrooms, you need to really look at the operational cost. And then adequate fresh air, again, because a lot of human beings would be there, a lot of occupancy load would be there, a lot of people would be breathing in and breathing out, inhaling and exhaling. We need to have adequate fresh air. Then different zones, again, in institutions, like you may have classrooms, you may have labs, you may have libraries, so which requires different temperature zones, which needs to be considered while designing a system for an educational institution. So what are the typical types of air conditioning systems that you consider for residences, showrooms, and educational institutions? You can consider a fixed speed air conditioning system, an inverter based air conditioning system, or you can also consider something called a VRF or a VRV system. In fact, I have made earlier presentations on all these type of technologies. In the earlier presentations I have made, probably you can just look into the YouTube. You would find these presentations there, which would be of interest to you to understand what is the technology that these go through. So these are the various types of indoor units. Like residences, you need to have various designs. There are each architect would have a different taste. They would prefer to have a typical varied type of indoor units. So what are the typical types of indoor units? You would have high wall type, then you have floor or ceiling mount, then you have something called as a concealed unit, where you can conceal this unit with a wooden boxing or whatever gypsum boxing, whatever type of boxing you want to do. Then you have something called as a floor mount, which is called as a slim pack. Then you have a one-way cassette, you have a two-way cassette, and you have a four-way cassette. Why is it called a one-way cassette? Is, if you see here, the distribution of air is in only one direction. That's why it's called a one-way cassette. In this here, you have distribution of air on two sides. That's why it's called a two-way cassette. And in a four-way cassette, you have distribution of air on all four sides. Then the next thing what you have is something called as a slim duct, which can be used in your bedrooms. Then for larger living areas, you can look at a medium static ducted unit. And for bigger, larger volumes, you can go for something called as a high static ducted unit. Typically for showrooms and all, where the volume is more, you can go for either a medium static ducted or a high static ducted, but I would not recommend this medium static ducted or high static ducted, especially a high static ducted for a residence, because that would make some bit of noise. So I would suggest a slim duct or a medium static ducted unit for residential application. And also, if the showrooms are smaller, I would suggest this slim duct or the medium static ducted type of air conditioning indoor unit. Then these are the condensing unit. You have an inverter where you have the symbol for any inverter air conditioner. You will have the symbol which denotes inverter, which saves power of about 30 to 40%. And then you have fixed speed, where which a conventional air conditioning system, which is called a fixed speed air conditioning system. So you also have a VRF outdoor unit, which has multiple compressors, single compressor. You have something called as a top discharge, and this is known as a side discharge in smaller capacities is what you get. Then, so industries is the next step, which is again furthermore challenging when we talk of industries. Why? Because what are the varied types of industries? There are plenty. I have just tried to list it out a few of the industries here. You have mechanical industries like tool and die making, CNC manufacturing, machine manufacturing, any kind of manufacturing setup, mechanical manufacturing setup industries. Then electronic manufacturing industry, electronic assembly, testing and packaging. Then you have automobile assembly areas, you have casting and foundry, you have packing materials, pharmaceuticals, day in and day out, separate different type of applications are used in pharmaceuticals. Then you have printing today, to dry the ink so that the smudge doesn't spread when you print, so it has to dry immediately, so you have to control the humidity. I would just like to talk about each of these application in a very brief, because each one is a different topic in itself. We would like to take a long time if we get into the depth of the types of air conditioning system. I would just like to highlight a few of the important aspects that need to be considered. Like if you are taking in a mechanical tool and die making machine, you need to consider the exhaust coming out of the system. Every system would have an exhaust to remove, and you also have something called as a coolant, which cools the equipment that is being manufactured there. So for that coolant, you have cooling that coolant, you have a refrigeration system. So you need to consider that heat which comes out of the coolant for designing, and also the volume. You would have 8 meters, 10 meters, huge volume of space that needs to be cooled in industries, which needs to be considered when we talk about design. Similarly, when it comes to electronic manufacturing, you have to have a dust-free environment. Most of the electronic manufacturing areas are clean rooms. They would have either class 1 lakh or class 10,000 or even class 1,000, depending on the type of application what they have. So at the same time, we need to have adequate cleanliness in the air. We need to have a controlled environment as far as dust control is concerned when we talk about electronic manufacturing or assembly areas. Automobile industry, like I said, again, a lot of testing would be happening. You would have to remove all the smoke, etc. Again, you need to consider a lot of ventilation when we talk about air conditioning and automobile assembly. Casting and foundry, lot of heat would be there, because they would be melting all your iron, they would be melting there. That would emit a lot of heat. So when we design these kind of systems, lot of challenges would be there, which we need to consider while designing a system. Packing material, similarly, when you smell these cardboards, etc., this emits a lot of smell because of the glue that is used in the packing material. So that smell has to be removed. Otherwise, on a long time, when you are staying in this area, you might start feeling uncomfortable. So packing material, adequate care has to be taken. Now, coming to pharmaceutical, you have wide range tablet manufacturing, you have formulation where your syrups are manufactured, then testing area, your R&D area, your quality control. Pharmaceutical requires a different type of system, especially if you have a chiller where you are going to use manufacturing facility. There you have to, sometimes you need -4 degrees, -6 degrees temperature, where you need to have a brine solution as a secondary refrigerant instead of water, which is generally used in a chilled water system. So pharmaceutical industry, again, is a huge industry when we talk about air conditioning for pharma industry, because there is varied kind of application. I have just given you the brief that wherever minus temperature application is required in pharma, you need to go with a brine solution chiller and not a conventional water cooled chiller. Similarly, in printing also, it depends on the type of ink that you use for printing. That needs to be dried immediately, otherwise the printing will spread everywhere. And these printing inks also emit some amount of smell, so that smell also has to be removed. So you need to have adequate ventilation. So these are some of the types of air conditioning system what we need to consider, the design considerations what we need to make when we talk about industries. Then I have been talking a lot about this ventilation. So what is this ventilation? Ventilation is nothing but air in and air out. So why do you need ventilation or air conditioning? Is to enhance human comfort, keeps the environment clean and dust free. It keeps a healthy ambience. At the same time, it also keeps in a lot of fresh air coming in from outside, which keeps the ambience very, very healthy. Then why ventilation in industries? Ventilation is the process by which, like I said, if you just Google what is ventilation, it is which says that bringing in outside air and removing stale air from inside. That is known as ventilation. That means in common words, it is called as air in, air out. So you bring in outside air, which we term it as fresh air, but again, it depends on how much fresh the outside air is. But at the same time, not only bringing in fresh air, you also need to remove stale air from inside through an effective exhaust system. So that is known as ventilation. Bringing in both fresh air as well as removing stale air through an exhaust system is known as ventilation. So then I have been talking a lot about air changes. What is an air change? Air change is how many times air is taken from outside and how many times the air is removed from inside. This process is known as air change. Hope I have just given simple terminologies which everybody would be able to understand. Air changes per hour is the rate at which the air is exchanged. That means bringing in outside air and removing inside air in 1 hour is known as air changes per hour. So every specific application has got a specific required air changes. So where do you get that air changes? What are the kind of pollutants what we have? We would have vehicular pollutants, we would have traffic pollutants, industrial emissions, construction and demolition, power generation if it is coal based, then burning of garbage, disappearance of green areas and lack of trees would add to pollution. Then indoor, what would be the pollutions? Indoor, outdoor untreated air. That means if you are bringing in untreated air from outside, like I said, the fresh air, so-called fresh air, if it is untreated, then that would result in air pollution. Then combustion of biomass fuels inside, burning of coal. Then your furnishings, you have a lot of volatile organic compounds. Like I said, the smell out of cardboard is because of the volatile organic compounds. Then you have paints and solvents, that those are these chemical fumes. Then cleaning agents which you would be using to mop the floor, or you would be using to clean some of your machineries. So those cleaning agents, also those smells have to be removed. The fumes coming out of them have to be removed. Then biological pollutants like dust, mites and pollen also has to be taken care of. Then infectious agents produced through your mattress, carpets, etc. Then improper ventilation and infiltration. Like for example, if you have a lot of air leaking out, or if you do not have proper filtration, that which results in infiltration, then that would result in air pollution also, indoor pollution also. So where do you get these ventilation standards? You can refer ISHRAE handbook on ventilation or ASHRAE standard 62.1 on ventilation standards, or you also have something called as NBC, that is called as a National Building Code, where various ventilation standards that is required is given in these references which you can refer for specific application. Now coming to the most important part today, which I would feel is air conditioning in hospitals. Why air conditioning is required in hospitals today is a regulatory compliance. I am not too sure how many of you have heard about something called as National Accreditation Board for Hospitals, that is called NABH. They have a guidelines which they say that for specific type of hospital, you need to have specific type of air conditioning system, which is called as a regulatory compliance. So we need to meet the regulatory compliance if you need to get the hospital license. Then operational hours, it would be 24/7, 365 days. Then infection control, you need to control the infection without spreading the infection, because a lot of us would be carrying various types of infection when we go in as patients. So the infection should not spread. You should control the infection. And how do you control the infection? By having the adequate rate of ventilation or the air changes, that what we discussed. Like I said, every specific application in a hospital has got specific air changes, and these guidelines are available again in ISHRAE standards for hospital air conditioning, or you have something called as NABH guidelines. Then accreditation licensing demands, like I have explained earlier. Then indoor environment quality, we need to keep the people inside very comfortable. We need to have what needs to be considered as the right kind of comfort level or the quality of air that we need to maintain. Then again, ventilation and environment restrictions is what we need to be considered. Then why air conditioning in hospital? Like I said, 24/7, 365 days. So what are the various zones? There are separate zones like your emergency room, operating room, labor room, OPD, different types of OPDs like your medicine, pediatric, laboratory requires different type of air conditioning system. Then you have in surgical, you have orthopedic surgery, you have gynecology, you have neonatal care, then you have inpatient department, you have physiotherapy, then you have various lab, then some of the areas which completely needs air conditioning in an enclosed space is very, very important in hospital, is why we require air conditioning system. So then we also have something called as in hospitals, we need to take proper care in a positively pressurized room. If it is an infection zone, we need to maintain proper pressure. That means air from this zone can only move out. That means this room has to be in positive pressure when compared to the other zones outside the other areas. So this is known as a positive pressure room, and where you have a lot of infections, this we call it as a negative pressurized room, where from the outside area you need to bring in a lot of air to remove the infection, etc. And this is known as a negatively pressured room when compared to the adjoining areas. So this is very, very important, where you need to maintain positive pressure and negative pressure in a hospital environment. So where do you use again applications for hospitals? You have IVF clinics, and again smell removal, then radionuclides removal, decontamination, then equipment protection. So these are some of other applications in hospitals. And maintaining good indoor air quality is a significant concern in hospital settings. Understanding how to control the various type of hazards is very, very important, and especially when you are designing an air conditioning system for a hospital, you need to take additional care, because you are considering human beings as the most important part on the earth. So when we are designing, we are trying to maintain we are playing around with the lives of human beings. So we need to take special care when we design an air conditioning for a hospital system. Then, so where do we get these standards? ISHRAE IEQ standards. Again, you find now then also ISHRAE is on the verge of bringing in health guide for healthcare facilities, which would be released shortly. Then, like I was talking about various zones to be controlled. Now, like you see, class B and C operating theater rooms, you need to maintain a temperature of 68 to 75 degree Fahrenheit or 20 to 24 degrees centigrade with an RH of 30 to 60%. Then you need to maintain a positive pressure. That means you need to have minimum 4 outside air changes, and at the same time you also need to have 20 air changes per hour. So these are some of the recommended indoor air changes. This is available in all your guides like your NABH guidelines or your ASHRAE guidelines or your ISHRAE guideline for healthcare. These guidelines are available, which can be referred when you design a typical system for an air conditioning system. So with this, I think I will stop sharing my screen. I have given a brief explanation of what needs to be done and how air conditioning system works in varied kind of applications. Now we are open to questions. Thank you.
Madhukar, the only word I can tell is wow. What a presentation.
Thank you.
I think with the last presentation and today's presentation, you have made a wonderful learning experience for us.
Thank you.
I think you have given an insight into the world of refrigeration, world of air conditioning. I myself being in air conditioning trading line, I was not aware that there was such an wide variety of aspects to be taken care when an air conditioning system has to be designed. Now, I think day by day, everywhere we see air conditioning, and I think you have classified the total world of air conditioning into different categories like residences, hotels, and hospitals, and each one of them requires a different type of designing of the air conditioning. So that is really great. I think we have got a lot of inputs on air conditioning. I think all of us here who are hearing this webinar would have got a lot of insight, like what are the different types of air conditioning, how it has to be controlled at different locations. Now, I think with this, I think the members must have been got into a great amount of learning. And if anybody of you have any doubts or questions to be clarified, I think the speaker is there for us. So can we get some questions from the members? I think before we go ahead, I had one or two doubts with you. I
please
think
go on, sir.
we talked about the importance of ventilation. So we were not aware about this importance of ventilation. You have brought about the importance of ventilation in your speech today. Even when I went to these hotels and all, in some of the hotels I used to get the food smell or the chicken smell, and they were creating a sense of uncomfort. But today I understood by having a proper ventilation and controlling that, we can get a clean and smellless environment. I think thanks for giving us that information. And one question I had to ask was this VRV and VRF, and then fixed speed. These are two different categories of air conditioning. Where are they specifically used? Because I understand VRV, VRF are large systems, and fixed speed is, and the inverter is small air conditioners, like room air conditioners.
No, see, a VRF or VRV system is used where you have limitations of condensing unit space requirement. So you can have multiple indoor units connected to one outdoor unit. That is the advantage in a VRF system. Whereas if you go with a fixed speed system, you will have in fixed speed system, generally what happens is you will have one indoor and one outdoor. Let us say, for example, you are air conditioning 10 different zones, then you will have 10 different systems. So 10 different outdoor units, 10 different indoor units. So you may not, if you look at a typical hotel space, you would have a complete building facade with outdoor units. So instead of that, you can go in for a VRF system where you can have multiple indoor units connected to maximum of say 22 HP into 4, that is 88 tons, can be connected as a single module. So you have limited space that can be used for outdoor units. So that is the major difference between an inverter air conditioning system and a VRF system.
Yeah. So it is irrespective of the size or tonnage.
Capacity, yeah. You can even residences, you can use up to 5 tons, 6 tons also, you can use a VRF system.
Okay.
But only thing is you will have single condensing unit catering to all multiple indoor units.
Okay. Thank you. And the second, you told about this inverter air conditioners saving lot of power. And you told especially for showrooms, no? Where people come once in a way, sometimes there's a lot of rush, sometimes there's less rush. So such cases, you told this inverter ACs are better actually.
Correct.
But my question to you is, does the inverter AC really save power? Because
100% it saves power. 100% it saves power.
Madhukar, my doubt is, in the normal air conditioning, maybe about 30-40% of the time, the compressor is off. It is not working at all. And 60% of the time, it is working. Whereas in inverter AC, the compressor keeps working for 24 hours. So if you compare the power consumption of both the sides, does inverter really save the power?
Okay. Do you have a paper and pen with you?
Yeah, I have. Yeah.
Please calculate. Then you tell me which saves power more. Okay. I will go by your theory only. A fixed speed 1 ton system consumes a power of 6 amperes. Okay. This is just an assumption. It could be anywhere between 6 to 8 units. Okay. 6 to 8 amps. Okay. So let us take for simpler calculation, let us take as 6 amps for a 1 ton air conditioning system. Okay. So for 1 hour, if it is consuming 6 amps, P is equal to, that is power is equal to voltage into current into power factor. That is Ohm's law. Okay. So for a single phase, your power factor is 0.8, but generally we consider as 1. Okay, so voltage into current will give you the power. So that means P is equal to VI. So 220 into 6. If you also have a calculator, you can calculate
Yeah, I can
220
make
into
out.
6. I will also calculate parallelly. 220 into 6 is 1.3 watts.
Okay.
Divided by 1000 will give you 1.3. So that
Okay.
means 1.3 units will be
Yeah.
considered for a 1 ton air conditioning system if you run for 1 hour. Now in
Okay.
this, I will come to your logic only. Generally, it is considered as 30% of the time it is cut off. Okay, 70% of the time the compressor is running. That is the guidelines which has been done by a lot of research, that 70% of the time the AC will be running. So now this 1.32 into 70%, it will be 920 watts. Okay, now let's come to inverter. Okay, let us assume that you have a 1 ton air conditioning system in an inverter system. Okay, you switch on the air conditioning system, the compressor starts at 0 rpm, runs at full speed. Okay, then as the temperature starts dropping down, the rpm of the compressor also starts dropping down. When the rpm of the compressor starts dropping down, your amperage also starts dropping down. Let us say, for example, to maintain a constant temperature of 25 degrees plus or minus 1 degree centigrade, the AC that is required could be only 0.5 tons. So then what happens? Your power consumption reduces down to 3 amps on the same lines. So coming to 220 into 3 is 600 watts. Now you tell me 600 watts is more or 900 watts is more?
600 only.
600 watts is less, 900 watts is more.
600 is less actually.
So which saves power, inverter or fixed speed?
Inverter saves power.
I will give you another example, common man's example.
One doubt I have again.
Yeah.
Now you told 3 amps is the power consumption. But in the initial period, it may be more, I think. Na?
That is hardly for about 5 minutes.
Oh, that's
5
all.
minutes. That's all.
That's all. Okay.
5 to 10 minutes is what, if you design the system properly.
Okay.
If you put for 300 square feet, if you put a 1 ton AC, if you run for full day also, it will run at full speed only.
Okay.
So you need to design the capacity properly to achieve the power saving, whatever I'm talking. Now, in a common man's language, I will give you both again in common man's language. I will give you an example. When you drive car in your city, does it give you more mileage, or on highway it gives you more mileage?
Highway is more mileage.
In fixed speed is like driving your car in city, where you brake, you accelerate, you change gear, keep moving. Inverter is like driving your car on a highway. You maintain a constant speed.
Okay.
That is point number 2. Then coming to your capacity again, the time taken. If 4 people sit on a scooter and you extend the scooter to pull, it consumes more fuel. So that is what happens when you have an under-designed air conditioning capacity also.
Okay.
Irrespective of the type of system what you use, you will not save power.
Okay. Okay. So that point is clear actually.
Yeah.
I think we have one question from Mr. Rupal Panchuri. He wants to understand the difference between VRF and VRV.
Both are same. It is just the terminology, what I would call it as. Some brands call it as variable refrigerant flow systems. Some brands call it as variable refrigerant volume. It's a generic name, that's all. Each brand has got a different generic name, but technology wise both are same. It is called variable refrigerant flow or variable refrigerant volume.
Okay. Now there is Mr. Naveen Narayan. He has a question for COVID rooms. Separate air conditioning type required.
Yes, sir. You need to maintain negative pressure. You need to maintain negative pressure, point number 1. And when you take out the air, you have to remove all the virus. It has to pass through your UVGI lamp. It has to pass through your HEPA filters, and then the air has to be let out. Okay. You definitely need to have a specified application system for that.
Madhukar, negative means that means outside air should come inside.
No. But outside air should come inside the infection zone.
Okay. And infection air should not go out.
Infection air, the infection to be negated. It should be made to 0 infection and then it should be let out.
Okay. Understood.
You have various levels of filtration for that to remove the bacteria and the virus.
Oh, okay. Oh, there are various levels of
filtrations
for bacteria.
Yes. You need to pass it through a UVGI lamp and a HEPA filter.
Okay. Yeah, we have a comment from Mr. Nanda Kumara. Very good presentation, refresh and in-depth of air conditioning. I think we already got 3-4 comments from various members telling us that the presentation has been very good actually.
Thank you.
And from Thiruvanna Arasu, excellent
Yeah.
information to the beginners. Rotarian K. Thiruvanna Arasu.
Thank you,
Again,
Thiru. In fact, he is from Madurai.
I see. Okay. Naveen Narayan, good presentation, sir.
Thank you, sir. Thank you.
Okay. Vyas Narayan, nice presentation.
Thank you.
Yeah. I think people have liked the presentation. In fact, I liked it very much actually.
Welcome.
I was
sir.
thinking about this from a long time. I should know the different variety of air conditioners. But after hearing to you in the last 2 sessions, I came to know how big is the world of air conditioning, how different are the design aspects for each of them. So it's really great actually. Thank you, Madhukar, for this wonderful presentation. I think with that we will close the question and answer session, and I will hand over the stage to Mr. Nagaraj. I request Mr. Nagaraj to summate the program of today and then propose the vote of thanks. Mr. Nagaraj.
Yes, sir. It was a really fantastic presentation. I need not to say anything on that. I think you are our favorite speaker also, Madhu. Thank you so much. I think today's session is what is it? Then ton of refrigeration. Definitely, these are all basic things you have told us. Then air conditioning in residences, what all to be considered. Air conditions in showrooms. There, how we have to different materials should have a different temperatures, maybe RH or temperature. Then educational institutions, what should be considered. Then industry, different industry have different requirements. Then most probably the most these things you have told us in hospitals as per NABH, National Accredited Board of for Hospitals. So what is the standards we have to maintain? Then IAQ standards in history, what they are all given. Really, this is in a short span you are given a variety of things to the delegates. Definitely, this is a wonderful presentation in a short while. I think as Prasad told, even I also like very much. Thank you so much your presentations.
Thanks and welcome, Nagaraj.
This is what I can summarize. I think delegates have got more information from you, no doubt about it. From Rata, Bangalore, our sincere thanks to Mr. Madhukar for a wonderful presentation on types of air conditions and applications, Series 2. Thank you so much, Madhu. Thanks a lot for your time and effort to the society.
Welcome, welcome.
Then thanks to Rata head office persons for handling online hosting. Thank you so much. Thanks, Prasad Garu. As usual, your more active participation. I think most of the questions the delegate should ask, so their mind, what is there, you will capture and ask the speakers. Thank you so much. Then last but not the least, without audience, we cannot do the programs. Thanks to the delegates for their active participation. I think our past president of Madurai and past regional director of South Region 2, Mr. Tirunakar, so we are acknowledging here. Thank you so much, Thiru. And once again, thanks to all for the success of program. Thank you so much.
Welcome.
We can close the session. Thank you, Madhu. Thank you very much once again.
Welcome, welcome. Thank you. Thank you all. See you.
Thank you.
Right.
See you.